recording. Okay. So let me see. We had a test. Grade the test yet. I'm behind, but let's look at the syllabus. And there are two tests which we've now had, which are 30%. The final is another test, 15%. That will be in the finals week. Final exam schedule, there it is. We meet Monday, Wednesdays at 12:30. So we are at 12 on Monday the 13th. So that's when the test is scheduled for. So that is that third test, which will be on SQLAlchemy and Flask and Python, sort of everything together. The homeworks were worth 15. The labs are worth 30. The project is worth 10. I will give you a list of criteria for the project. But the homework and the labs are together 45. Even if they're late, they're still eligible for 90. If you get them in on time, they're usually 100. And so this almost half of your grade can be in the 90s or 100 if you just do it all. And if you can't do it all, ask for help. That's how this is supposed to work. The tests are 45, so they're not quite half. And then there's this project. I will give a list of things. So it'll be like a lab, a lab or 2 or 3, or sort of say, here's what you should have, all these things. But it's toward the end of the semester, so it'll be, I'll give you some time to do it, but it will also be based on this more recent material. So there'll be a database. You'll be making your own database for the project. So hopefully I will lay out some criteria and give it to you before Thanksgiving so that if you hate your family, you can think about your project over break. All right. Okay, so that's what's coming up. A project, one more test. Chat. Okay. So there's a new homework, which is an ER modeling exercise. I will do one in class and then teach the next little bit of SQLAlchemy meets Flask meets WT Forms, and then I'll let you leave it over to you to do the lab. So let's look at this ER modeling exercise. So it's going to give you some scenario, and then we're going to pick out things that will be in the tables and so on. Okay, there we go. So in this scenario, Santa needs a database. Santa has to track children. So they have names and addresses and birth dates, and we have to know if they're naughty or nice. So that's things we need to know about children. Santa also follows the toy market, so he keeps track of toys. The toy might have a name, a description, and the age level for the toy. And then the toys are made by toy manufacturers. So, and those manufacturers have a name, a location, contact name, phone number, or something like that. Okay. So then children want toys, and then children get toys. So that's 2 relationships between children and toys. And that's possible, that there's multiple relationships between 2 two entities. And so we're supposed to state the relationships in both directions. So we would say that, you know, a child wants many toys, and a toy is wanted by many children. And then once we figure out the relationships and the entities and their relationships, then we'll figure out the tables from that. And then we'll write down the tables and say, oh, here's the primary key and here's the foreign key. Okay. So we can sort of identify the, I don't know, the nouns. Those will be our basic entities. So we don't have to keep track. It's Santa's database. We don't have to keep track of Santa. We just have to keep track of the things that Santa has to keep track of. And so there are toys, children, a child, and toys or children, and toy manufacturers are the things mentioned. Okay. And then we need our relationships between these. And there were two relationships between toys and children, the sort of wanting a toy and getting a toy. That was two different relationships. And then there's the toy manufacturer. So let's do the toy manufacturer first. That is easier. And I told you that I like this relationships expressed in both directions. So now it depends what we mean when we're entering toys in here. Like if you said doll, then there are lots of manufacturers of dolls. But if you said specifically the Barbie doll, then that's made by Mattel. So we have to figure out the relationship. We have to figure out what kind of information that we mean to store. So I'm going to say that my toy is going to be unique enough. You know, the toy is going to be each sort of, I'm not going to have something more generic like a doll. I'm going to have something quite specific like, you know, Dr. Barbie or something like that, who's made by one manufacturer. So the toy is made by then one manufacturer. But a manufacturer makes many toys. So that here's the one, and here's the many. And so that relation between toy and manufacturer is a one-to-many relationship. And what do we have? We had a relationship between a toy and a child, and there were actually two. So, and these always start with a toy, and then here's the one or many. And that's why I need to express it in both directions to get, are they both ones, are they both manys, or there was the one and the other one many? Okay. So what comes next? I will start with a toy is wanted by many children. And a child wants many toys. So that is then a many-to-many relationship. And then we finally have, there's another relationship a toy is given to many children, and a child is given many toys. So that's another, there are two relationships between children and toys, and they were both many to many. Okay. Now let's start thinking about making tables. A toy has what properties did we say? Toy has a name, a description, an age level. So I'm probably going to give it some toy ID, be all databasey. And then it will have a toy name. And you can come up with other names. And this is just an in-class exercise. So you don't have to turn this one in. There's a different one for homework. That's what you have to do. And there are different notations. This is just a notation I'm using for a table. Here's the toy table. There's going to be a toy ID, a toy name, and a toy description, and a toy age level. That will get us started. And there may be more, but I don't know it just yet. And then I'm going to have a child. And so I'll have a child ID. I like IDs and databases. What else did we know about children? The child had a name and address and a birth date, and whether they were naughty or nice. So there was a child ID, there was a child name, child address. There may be components of an address. I'm not going to get that all into it. Name, address, birth date. And the child, naughty or nice. Okay, so we just say naughty. That would be a Boolean, yes or no. Or maybe there's more categories than that. But maybe there's a level of 0 to 10, who knows? Okay. So that is, I may have to come back and do more child stuff, but that's my start of child just by what's listed in here. And then the manufacturers. That's too long a word. We'll have, I'll call it manuf ID, and what properties were listed up in here about manufacturers. There was a name, a location, a contact name, a phone number. Okay. So there was a name, there was a location, there was a contact, there was a phone. So those are the things explicitly mentioned in the, other than the IDs. So I had a child at a manufacturer. I gave them what was mentioned in the paragraph alone. Okay, so that's what I've got. Okay, so far. Now I have to start looking at the relationships. Our idea in a database is that a property for a record, for a child, the child's going to have one thing in here. So the child will have one address. The child will have one birth date. Okay, that is our assumption about a database. If we think that a child has multiple addresses, that, then we have to start considering a different database. We're going to assume the child has one address, the child has one name, the child has one birth date, and the child was, I don't need any long explanations, they were naughty or not. Okay. So that is our idea of having just one simple thing in each box when we fill our database. And so when we have relationships, we can put the manufacturer into the toy table because there's a one. So the toy is made by one manufacturer. That means I can come to my toy table and add the toy, or I can add the manufacturer ID. And that's the way to make this relationship. So a one-to-many relationship is made by putting the ID. So we find the sentence which has the one in it, and we pick that entity that started that sentence, the toy, and we added as one of its properties the ID of the other table. Again, our basic idea of the database is that there should be one thing. So that's how this relationship is made, that there was a manufacturer ID in the toy table that establishes that relationship. The other two relationships are many-to-many. They cannot be made that way because they're both manys. So when you have a many-to-many relationship, you need another table. So I need a table that is, I don't know, the want table, and I need a table that is the given table. So I guess that's what I'll call them. So the want table is a table that's going to establish this many-to-many relationship. And there is a child ID and a toy ID. And that establishes the relationship between the child and the toy. So for each thing that, for each desire, for each want, there is a record that has a child and a toy. I'm not going to have the child wanting this toy twice. Maybe they want more than one, then maybe I would add, if I wanted somebody to be allowed to want more than one of a toy, then I can put in here a number. I want two of them. But this satisfies my rules that a table, a cell in a table, an entry cannot have more than one thing. So I cannot put in toy all the children that want it. I cannot put in child all the toys that the child wants. I have a separate table that connects a child to a toy. And I may allow for other things like a number, or maybe the child can say how much they really want it. I want it with, a factor of 10, or I want it with a factor of 1, or so I could have other properties, but the main two properties are these IDs establishing the relationship. And then there was another property of give or given. I said want, so I guess I should say give. And that's also between the child and the toy. And so these are all tables. And then I said I want to label things as primary key, so I'll say PK for all these to indicate primary key. You could underline them, you could put them in bold, or whatever you want, somehow indicate. The manufacturer ID was a foreign key. So the IDs were primary key. Why did I say PF? I don't know. Why did none of you stop me? I don't know. Primary key, foreign key. And then these were foreign keys. And again, foreign keys. Now, some people will come along and give this want table like its own primary key of like the want ID and the give ID. And that's a sort of a matter of taste. You establish the relationship with the two foreign keys, and that does the trick. And then you can decide either this is what I always do, or you can just figure it out scenario by scenario. Do you want a specific ID for the thing? So like a standard thing when you're ordering something is to have an order may have many items, and an item may be in many different orders. And so people often talk about the order line. And then then there will be a question of, do you want an ID that corresponds to an order line? I tend not to give them their own primary keys, but you can. And I usually refer to these as bridge tables, but there's probably like 5 other words for it as well. So that's the kind of thing I'm looking for in the ER modeling. So I gave you a homework, but that's an example of what I want. And I will ask you to do that also in the project for your database. So, and almost assuredly in the database, I will ask for the database of your project that there'll be at least one one-to-many relationship and one many-to-many relationship. So I will start thinking, if you're thinking, when start thinking about your project, make sure that you have those properties in your database that you can recognize a one-to-many relationship in what you're doing, and you can recognize a many-to-many relationship. But this little Santa database would have at least 5 tables. The main entities were toy, child, and manufacturer. But to realize the 2 many-to-many relationships, we needed 2 more bridge tables. Any questions on that? Yes.
Why does toy and child have 2 bridge tables?
2.
Toy and child, why do they have
Listen to that word. Why do they have 2
bridge tables?
bridge tables? There were 2 relationships. So a child tells Santa what they want. So first we're keeping track of what they want. And then we're also keeping track for historical purposes of what they were given. So that is, I wrote that as 2 relationships. Now you could say that we're just going to make a property of here's what the child wants, and then we'll check it off whether or not yes or no it was given. But sometimes children are given like socks or something like they didn't want. So we could possibly, with the right fields, turn it into one thing. You know, here's just some relationship between a child and a toy, and did the child have a yes, no? Did the child actually receive the thing, yes or no? And did the child actually want it, yes or no? So we could probably, with the right fields, it might be possible to merge it into one table with more fields, or we can make it keep it simple, but with 2 tables. But probably can be worked in either direction. And then you have to think about your queries. Am I making it easy or am I making it hard with, if I had one table or if I had two tables, am I making the queries hard or not? So it's not an exact science. It's not like there is this answer and only this answer for this scenario. You could probably get away with one bridge table, provided it had sort of more sophisticated fields. If you keep it really simple, just to say, here's this want relationship, but there's a separate give relationship, then you need two. I took that approach. But with a more sophisticated table, you might be able to get away with one bridge table. Any other questions? All right. So now back to some Python. But you have to make, for your project, you have to make a database and you have to sort of explain your database. So you have to do some of this for your project. Okay, so back to art. The previous time we inserted at the table. I have the painters painting table or database, and the painters have no foreign keys, but the paintings have a foreign key saying who painted the painting. So our first insert was when the table had no foreign keys, because that was the easier place to start. Now, today, we're going to switch over to the painting table and insert something into that. And we only want to insert a painting if it has a painter. And so we want to get the possibilities for the painter from the list of possible, So when I'm inserting a painting, I only want to put in foreign keys that correspond to actual painters. So I don't want to allow the user to just type in anything because they might make a mistake. I want to actually go to my database, find out who my painters are, display them to my user, and let them pick from the actual right ones. Okay. And then the lab will be for you to do the same. Okay, so here's this ever-growing example. I didn't extract it. I'm going to copy that. I'm going to document 341 into my SQLAlchemy into the VENV. That's where I'm going to paste. I'm overwriting some things I had before. And most of these things I had before because I defined the art database, I populated the art database, I had a route for the user to enter a form of the database, I define my forms here. So I'm going to add another form, and I'm going to add the route for that form, and then I must have in here, before I had artist form and artist form handler, I added painting form and painting form handler. Okay, let me start up my code. Let me make sure I'm pointing to open the folder. I'm in 341 SQL VENV. And I'm starting off with, let me start off with art forms. Let me start off with art defined, never mind. I have the definitions of my tables in art defined. And so here is the painter. There's an ID, a last name, a first name, a country, a birth date, a death date, and a relationship to the painting table. And I have a painting table with an ID and a title and a file name and The painter ID is a foreign key. A painting is painted by one painter, that's the one, and then a painter paints many paintings, that's the many. So we go to the one, a painting is painted by one painter, that's the part of the sentence, part of the relationship with the one, and we put, what we make the foreign key. So in the painting table, the painter ID is a foreign key. So that's our definition. Then we had our populating code. So we read, in my case, some JSON file. So there was this JSON file. And then I'm adding artists and painters and paintings based on that data file. So that was my populate. That was the same, and I ran some queries. That we had on Wednesday. No, yeah, Wednesday, last Wednesday. Okay. Then we had routes. So I had a route. I'm bringing in the forms. That's our normal, bringing in the forms is our normal Flask kind of stuff, but I'm also bringing in, where did I bring it in? The database. So here's my definition of the database I brought in. Here's my definition of my forms I'm bringing in. And then I have a route for the artist form. That's where I'm going to enter an artist. And that's what we did the last time. And then here's my new stuff. I am doing a little query to find out the artists. So here are the artists that I have, and I make a list of couples. So that's what I use to set my choices. And then here's my painting form. I'm going to come back and do it in more detail, but here are the new additions. I have a query to ask who are the painters, and I have a painting form where I'm going to insert a new painting. So that part, those are new things. Over in the forms, what's new over in the forms? I had to add a select field. I'm going to select the painter. I'm going to add a painting, and the painter is going to be in a dropdown, so I needed a select. Here's my artist form. We had that before. Here's my new painting form. I'm going to have the title of the painting. I'm going to have the file name for the painting. I'm going to have the painter ID, which is going to be a select. So you're going to see the names of the artists, and then you're going to, behind the scenes, it's going to give me the ID of the artist. And then I have a button to submit. So there'll be 4 things on my painting. I'll enter the title of the painting. I'll enter the file name for the painting. I'll choose from a drop-down list the painter of the painting, and then I'll click the button. So not too much difficulty here over in the painting form. The one weird thing is I don't put in any choices. I'm not putting any choices for the artist because I'm going to get them from the database, and I've decided to do that in the app, in the route file. Instead of doing it over here in forms, I'm going to do it in routes. Okay. So let me go over to routes. Here's a little section of code. Here's where I'm getting all the painters. I make a list that's empty, and then I'm going to loop through the artists. And I make, this is a list, but I'm going to cast it as a tuple in a minute. But I add in the ID of the artist, and then I add in the first name and the last name of the artist, and then I turn that into a tuple and add it to my list of artist choices. I printed it out just so I could see it, and then I actually commit. So I actually perform the query. Maybe I should have my commit in a different place. Okay. And then here is my form for the painters. I go to the painting form I defined over in that other file. My choices for the painter ID, remember that was a select. Now I'm deciding here what the choices should be. They're artist choices that I chose above. I've had issues in the past. It was working for me last night, but I've had issues in the past where my validate wasn't working. So I'm printing out whether it's valid or not. And I keep here is submitted, which is an easier thing. So if my validate fails, I swap back over to is submitted. But at least last night it was working for me. Here's me inserting a painting. Well, here's me making a painting object, and then here's me inserting it and committing. And then the usual, if it wasn't valid, go back to the form. If it was valid, move over to the handler. And so I need a new painting form and painting form handler, but that's sort of fairly straightforward. Here's the painting form. Don't forget the little token, but here's a place for me to enter the title. Here's a place for me to enter the title. Here's a place for me to enter the file name. Here's a place for the painter. And here's the submit button. So that's what the painting form will look like. And then the painting form handler is just going to spit things out. Here's the title you just entered. Here's the name here's the file name you just entered. Here's the ID of the painter you just entered. Okay, so let's see if this runs. So I run the routes. That's the thing that's Flasky, is the art routes. What am I doing? There's Flask run. Oh, this is the computer. Then I have to activate my VENV. Sorry. Okay, now I'm activated. Let's see if it runs now. And I'm getting an import error. Oh, that's what that's right. I made that mistake the last time, and I told you what the mistake was, but I did not fix the mistake because I'm stupid. I don't have WT Forms on this, so that's a pip. Install, I think it's Flask, WTF. Got it written somewhere if that's not right. Okay, now I have Flask installed. One more try. Here's my Flask run. Yay, okay. There are my artists. I queried my artists, and I have right now 11 artists because I've been checking my forms and adding artists. And okay, here I am. Now my default route is the artist table, but I'm going to go over to my painting form. Probably need some nice navigation, but I didn't make it. Here's my painting form. And now here's the new one in terms of insert. That with the foreign key, I don't want to have any violations of my database. My paintings have to have a painter. The foreign key has to be a proper foreign key. I can't put in, I have 11 artists right now. I can't put in a 13. There's no such artist. I don't want to give myself any database errors. So I only want to pick artists that actually exist. So I'll pick, almost everybody does a still life at their one time in their life. So there's a still life. Somebody did a still life, and I'm presuming I have some files, so I'll call it still_life. I like underscores. And then who made this still life? Pablo Picasso made this still, and I don't know why it says poop. That's just my favorite word. So, and then I'm going to insert the painting, and then here's the handler telling me that I just added still life. It was artist number 8, which was Picasso. And if I'm looking at in my database, I think that was Control-Shift-P, open a database. I'm choosing the art database. It has painters and paintings. There is Picasso, then I've added previously. And then in paintings, show that table. I should have that painting. I just added, I added still life twice. But one time it was by 10. I don't remember who 10 is, but the last time it was by 8, who's Picasso. So there's 8, which last time, my last still life was by John Singer Sargent, who doesn't do many light still arrows, so that was a bad choice. Picasso definitely did some still lifes. So that is the game. And basically you just have to, for a different database, do the same thing. So what was new in art routes, there was a query to get the foreign keys and then a new route. In the forms, in forms art, I had a new form. And then the one weird thing about this form was that I didn't have any choices because the choices are coming from the database. So I'm not making any hard-coded choices. I'm making choices, I'm leaving the choices blank and bringing them in elsewhere from the database. So over here in routes, here was the query of the artists that made, and then I put it into that tuple format that we like, and then use that here, and then went over to the painting form. So that's the idea. What are you supposed to do? The same thing. I did painters and paintings. You're doing poets and poems, which you can turn into song lyrics if you want, if you don't like poems. So we're going to have I had a painter makes many paintings. That painting was made by one painter. We're going to do the same thing. Poet writes many poems. The poem is written by one poet. You're going to make pretty much copy over, except with some editing, copy over. You will have a poem table, a poet table, some properties, the title of the poem, I don't know, style, something about the poem. It can be song lyrics. That's perfectly fine. Just our database assumes that their lyrics were written by one person. And so that's different from what we did for the Beatles. For the Beatles, a lot of the songs were written by 2 people. So for the Beatles, this was a many-to-many relationship, but we're assuming for now, then it's a one-to-many, because that's all we have done so far. And basically recreate that example I just gave you, but with some different data, maybe some different properties. Any questions? No, so let me stop recording and then let me get my attendance. People are all over the place. Stop recording.